Okay, so guys, so now I'm gonna talk about how to find the Thevenin voltage. And the Thevenin voltage for this schematic is basically uh, it's the voltage potential between A and B right here. That's the Thevenin voltage. So I've labeled this part of the schematic as ground. So that means there will be 0 volt right here. Um, and I've also labeled this as the point C. Uh, so so for the Thevenin voltage is just VA minus VB, and we know that VB is 0. So VA will be equal to Thevenin voltage VTH because VB is 0. Um, and VA is also equal to VC if you look at it, because uh, while you're finding the Thevenin voltage, this won't exist, and uh, there will be an open circuit here. So that means there will be no current flowing through the 10 ohm resistor, and because of that, voltage at VC is also equal to VA. So in order to find VC, we can use KCL at that point. So I'll just label this as I2, this as I1, the current going through the 5 ohm resistor, and the current uh, leaving point C as I3. So from KCL on point C, we know that I1 plus plus I2 minus I3 equals to 0. And what that means is sum of and what this is basically stating is the sum of the current leaving point C is equal, or I mean the sum, this I1 plus I2 equals minus I3 is 0. So because this is a node, the current going through has to equal to the current going out. So if you subtract two equal things, it'll be equal to 0. So that's basically what it's saying. Um, so we can solve this through. Okay, so we know that I1 is 20 minus VC over 5. And we know that I2 is 3. And we know that I3 is VC minus 0 over 5. So what this is this is just Ohm's law. I equals to V over R. So voltage at here will be 20 volt minus whatever the volt is at VC and divided by the resistance, which is 5 ohms, and plus 3. We already know I2 is 3, and for I3 we know that all the current leaving I3 will go through the 5 ohm resistor, and we also, because this is an open circuit, so all of the current will go through the 5 ohm resistor, and the voltage here is basically VC minus VB, which is 0, divided by 5. So that's why that works. So, and all of this was equal to 0. So in order to solve, I'll just multiply everything times 20. So this is 1, this is 4. So 4 times 20 is 80 minus 4 VC plus 20 times 3 is 60 minus that will again be 4. So 4 times minus 4 VC minus 0 equals to 0. So minus 4 minus 4, that'll be 8 VC. And 80 plus 60 is, let me just do it, it's 140. And so that's gone, that's on, okay, equals to 0. So negative 8 VC equals to negative 140, and VC equals to 140 divided by A. Negatives cancels, so I'll just do what's 140 over 80, I mean 8 divided by 8, so that's 17.5, that is 17.5. So VC is 17.5, and as we know, VC is also equal to the VTH. The Thevenin resistance for this circuit is 7.5. Yep.